Okay, so this video is going to be over comparing and ordering rational numbers. So hopefully you tune in to this. So first of all, let's explain what a rational number is. So we are made up of the real number system and rational number and irrational numbers. So most of the numbers we use are rational numbers. A rational number is a number that can be put in fraction form. So in the form of A over B. That is the official definition. But I like to say two questions. And if you answer yes to either of these, it means that they are rational. So if you put it in a decimal and it repeats itself, that is a rational number. Or if it has an ending, like 1, 2, 3, it doesn't go on forever, or like 1/2 goes, you put it in a decimal and it's 0.5. So if you put it into decimal form and it doesn't go on forever and then it ends, then it's a rational number. So if you answer those two questions, does it end or does it repeat itself? And you answer yes to either of those questions, then it's a rational number. So rational numbers, we're going to talk about integers. Integers are positive and negative whole numbers. So integers are positive and negative whole numbers. And so that's a vocabulary word that we want to do here. And now irrational number is a number that cannot be expressed as a fraction. So it cannot be put in the form of A over B. That's the official. But remember those two questions? Does it end? Does it terminate? If the answer to both of those is does it end and the answer is no, or does it repeat itself and the answer is still no, then that is an irrational number. The most famous irrational number is pi. So like pi, not like pie you eat, but pi, where we use it as 3.14 in like volume or surface area of circles. So you'll see pi dealing with circles, but that's irrational because it actually doesn't ever end and it doesn't repeat. It's like 3.141579. I have students that can do like 60 digits, but not me. So that is irrational. So comparing rational numbers. So basically comparing fractions. So if we compare rational numbers, so rational numbers and decimals. So 7/9 and 2/9. If I want to compare these, then if they have the same denominator, all I have to do is look at their numerator. 7 is bigger than 2/9, so I'm going to have the greater than sign facing 7/9. 7/9 is greater than 2/9. So as your kid, you'd think about like the alligator eating the bigger number. You can still do that, okay? So 7/9 is bigger than 2/9. But what if you have like 3/4 and 4/5? 3/4 and 4/5. Now these don't have the same denominator, so we can't really compare them until they have the same denominator. So I'm going to choose to put them in the same denominator. To do that, we find the least common denominator, the least common multiple. So you say what multiple has 4 and 5 as a factor? So I just kind of count up by the largest number. So 5 is the largest number, 5, 10, 15, 20. And I notice that 20 until I get to a multiple that both of them go into. So I know 20, I know 4 goes into 20. Then 4 times 5 gave me 20, so 3 times 5 is 15. 5 times 4 gave me 20, so 4 times 4 is 16. And now since they are the same, I can compare them. I just look at the numerators. 16 is greater than 15, so we do a less than sign. 15/20 is less than 16/20. So 3/5 is less than, 3/4. 3/4 is less than 4/5. Now, what about decimals? So if I were to compare decimals, 0.3 and 0.28. When comparing decimals, you look at place value. So we can start with the tens place, and since they are different, we can compare them. If they were the same, we would have to move on to the other place. And I'll do that one. So since they're different, we look at 3 and 2. Well, 3 is bigger, so that means that this is bigger. So we were looking at the tenths place. So you start looking at the largest place value, okay? And then you start comparing, okay? Well, let's say, well, what if this was 0.3 something, so 0.35. So with this, and the easiest thing to do here, I'll show you a trick. You can compare place value, but the easiest thing to do here is to make, with decimals, is to make them have the same number of digits behind the decimal. This one has 1, this one has 2. So to make it have 2, we just put a 0, okay? Then it's easy to compare 30 and 35. Well, we know 35 is greater than 30, okay? But really what you're saying is the 3's in the tenths place, so we go to the hundredths place, and 0 and 5, we're comparing the hundredths place, and 5's greater than 0, so that way. Or you can do the little trick too that I just did. Let's do that trick again. So if I have 0.237 and then 0.2375. So if I have this and you want to know what's greater, then you can say, well, this has 4, this one, and so I put 4, and now I have 2,370, 2,375. 2,375 is greater. Okay, so I put a 0 to make them have the same digits. You can do the same thing when you have 0.0005 or 0.001. So you can still do the same thing. You can still do the comparing place value. The tenths are the same, the hundredths are the same, and then thousands are different. We're comparing this 0 and this 1. Thousands are different, and 1's greater, so we know that one's greater. Or you can do the same thing where you have 4 digits here, so 4 digits there. And so this, zeros don't count, so it's just 5. And then over here we have the number 10, so 10's greater than 5. So you can still do the trick. 0.001 is greater than 0.0005. Okay, so you can still do the trick. Okay, let's order rational numbers. So ordering rational numbers, so we have 4/5, 0.93, and 0.9. And we want to order these from, what does it say? Order these from least to greatest. So when you're ordering rational numbers, you have to put them all in one form. The easiest form to put them in is decimals. And if you don't have a calculator, you should know how to change fractions to decimals by division. It's 4 divided by 5, so 4 divided by 5. And 5 can't go into 4, so we add a decimal. We can't just start adding zeros. We have to add a decimal because that way we don't change the value of 4. And then we start adding zeros after that. 5 goes into 40 8 times, 0 left over. So 4/5 is actually 0.8 as a decimal. So I'm going to write that underneath. And then I can order decimals, so 0.8. Now to order decimals, we want to line them up. Or, like I said, since this one has 2 place values, you can make them each have 2 place values. And that's kind of the easiest way to do it. So 2 place values. So now they each all have 2 place values, and now I can just look at the numbers behind the decimal and see. Least to greatest, 80, 90, 93, right? So instead of writing 80 or 0.8, 8 tenths, I'm going to write 4/5, and then 0.9, and then 0.93, least to greatest. Now, if you don't want to do the little trick, then you can line up your decimals to compare. So 0.8, 0.93, and 0.9. So you can just compare the tenths place because you want to start from left to right. Well, this 0.8 is least, and we know that's 4/5, so we can mark that one out. And then we compare, since these are the same, we go to the next place value Well, if there's not one there, we fill it in with a 0. We compare 3 and 0. The least is 0, so we know 0.9 goes next, and then 0.93. Okay, so that's how you order from least to greatest. Let's do one more. 5, 6, 0.8, and 82%. Okay, so 82%. So 5, 6, we can change that to a decimal. Like I said, the easiest thing to do is to change these to decimals. Put our point there. So 6 goes into 50. 8 times, 48. Then we have 20. 6 goes into 20, 3 times, 18. And you notice that it's just going to continue to repeat. So 5, 6 is 0.83 repeating. So I'm going to write that. 0.83 repeating. I'm going to bring down 0.8 because it's already in decimal form. And then a percent to decimal, you just move it 2 places, the decimal 2 places to the left. So the decimal's right here, 1, 2. So that would be 0.82. So to change any percent, you just move it 2 places to the left, okay? To change any percent to a decimal, move it 2 places to the left. So now I have them. Again, to order them, I can either line them up. Oh. And this just repeats itself. So line them up. And they all have 8s. This one needs to have a 0 for a place value. And so now I can compare. They all have 8s here, so it doesn't matter. So now I'm looking here. And I'm going to order them from greatest to least. So now I'm looking here, they're all different. So the greatest one is 0.83 repeating, but that's 5, 6. I'm gonna write it back in its original form. Then the next one is 0.82, but that is 82%. So write it back into its original form. And then the last one, 0.8. Okay? So that is how you compare and order rational numbers. Thank you for participating.